All right, number one. So the reason we're going through this is I want to make sure that we're good on percent composition because if time permits, or it allows us to get finished with this, we're going to talk about two things tomorrow that you guys have never talked about. One of them is number 4, which is a hydrate, and then we're going to talk about mass spec tomorrow. Have we talked about hydrates? Spectacular, then that makes me happy then. So we're going to run back through that, and that's fine. We'll go back through it because I want to make sure everybody's on the same page. Number 1, it says percent composition. Calculate the percent composition for each element in CH4N using 2 decimal places. So we've got to do CH4N. Now, what we're doing is percent composition. What does a percent stand for? Part over whole. So we're trying to determine exactly how much of this entire thing is made up by each part. So how many parts, how many elements are there? 3 elements, but how many parts are there? 6 parts. Okay, 6 parts. So we're trying to figure that out. So this is how I've always taught people how to do it. C, H, and N. Label what you got. Okay. Next, how many of each are present? How many C's you got? How many H's? And how many N's? 1. Then what do we multiply it by? The mass, carbon is 12.01, hydrogen is 1.01, and nitrogen is 14.01. And then we do some basic math. So we've got 12.01 plus 4.04 plus 14.01. So that gives us 0.6. And would you say? 30.06. Okay, so that's our total mass. Would you agree? Now I'm just going to go ahead and throw this at you because it's going to become very, very, very important over the next few weeks. Does that number at the bottom have a unit? Thank you, ma'am. Say it one more time. Grams per mole. It is important that per mole is a part of it because if I have 1 mole of CH4N, no, it has to be per mole. Okay, it has to be per mole. Okay. Now, if it's a molar mass or a formula mass, it has to be that. Okay. Now, we have our parts, correct? How do we get our percentages? Divide. No, that's empirical. Divide each part by its whole. Okay. So divided by 30.06, and we've got percentages. Okay. Absolutely. Come get one of the yellow ones. Dustin, you got any numbers? All of them. The first one. I need the percentages. Tristan, go ahead. It says using 2 decimal places. Actually, that's for the mass, so we're just going to use percentages. 40 what? So does logic make sense here? Does your highest mass of the part have the highest percentage? Yes, okay, we're good there. Yeah. Now, I'm going to be honest with you. Number 2 is a little weird. I don't know why I want to waste time doing it, because I've never seen a question like this. No. All you do is, correct me if I'm wrong, Dustin, you take, no, that's not right. Yep. Yep. Yeah, I don't like that question. We're gonna skip B. Okay. All right. I'm gonna skip B. All right, number 2, empirical formulas. Calculate the empirical formula of a compound that contains 71.72% chlorine. Okay, so 71.72% Cl. And then it says 16.16% oxygen, and then 12.12%. I know exactly where this is going. It's going to be really easy. Carbon. Okay? We're trying to find the empirical formula. Now, based on the definition, what is the definition of empirical formula? It's the formula with, it's the most reduced form. Okay? Empirical means the simplest whole number ratio. There's several rules involved with empirical formulas, but it's pretty simple. It's very methodical once you figure it out. However, percentages, we don't like those things. What can we do with percentages? Drop it, change it to grams. So we're going to get rid of that. We're going to change it to a G. Drop it, change it to a gram. Now it's really easy. Okay? What's your next step in all empirical formulas? Convert grams to moles. Okay, so we're going to go grams to moles of Cl. We're going to go grams to moles of oxygen. And guys, I know that I'm not writing the compound in it because we're working within one compound. We're not getting out of it. We're staying in it. Okay, so what's your mass of Cl? Mass of oxygen and mass of carbon. Sounds good? How did you forget that? Of all the things to forget. Alright. What are our number? Anybody got your number of moles for chlorine? Oxygen. I added a 0. And then carbon. Okay. So that's our number of moles of each. Would you agree? And then the most important step, Elizabeth. What's your next step? Now we divide by the smallest. Which one up there is the smallest? Now, is there really that big of a difference between oxygen and carbon? No. So, we know that both of those are going to turn into what? That's a 1, and that's a 1. And I know you are smart enough to know that what does chlorine turn into? It turns into a 2. Now, if we were on a test, would you have earned full credit if you stopped right here and went to the next problem? No. What was the original question? The empirical what? What's that F word? Have you written a formula? Write a formula. Now, why did I write that? Now, hold that thought. We defined empirical how? The simplest whole number ratio. Can that be simplified anymore? All right, now I'm going to build an extension question that's not already on the sheet. So here's my extension question. What if So, hold on. Nobody, just let everybody absorb it for just a second. So, what if the molar mass of the compound is found to be 296.73 grams per mole? What is the molecular formula? Now, last year I gave you guys a little cheat. Does anyone remember the cheat how to convert MF to EF? Okay, this is the cheat. Okay? So what you do is you take the mass of the MF. How do you know what the mass of the MF is? It is given to you. And no, that is not profane language. So don't give me the weight of your best friend. Nothing. Nothing. So, we've got to be able to figure out what the molecular formula is. So the mass of the MF is given, and then how do you find the mass of the EF? So you got to calculate it. Thank you, Dustin. Okay, so here's the deal. The mass of the MF is going to be 296.73. I want you to try to find the mass of the EF. Do not say anything out loud. You have a phone, you have a calculator. You already have the masses of those three elements written down in the previous step. So calculate the molar mass of the EF. Do not say it out loud. You have a question pertaining to this. Will it give the answer away? So, what's the mass of the empirical formula? 98.91. Now, when we do this, this is the mass of the MF divided by the mass of the EF. If you divide that, what should it come out to be? Now, again, I ask a very simple question to you. If you stop there, would you earn full credit? No. The question is what? What is the molecular what? Formula. There has to be a formula. That 3 is important. What do you do with that 3? Multiply it to the subscripts. Very good. So your final answer is now what? Cl6O3N3. Did it again. Here's the deal. Here's why I keep writing that. I have never, ever done a compound where C is at the end of it. C is always at the beginning. That's why I keep writing in. I'm used to writing in. Ma'am. Did you round your things right? Your mass of chlorine should have been 35.45 times 2, which is 70.9. Alright, so that, I see there's a problem. So let me, and I want to go back, and I know you know this, but it makes me feel better to say it all out anyways. Why is that green formula that we have written not the empirical? It's not simplified. It's not the most reduced version. So Mason, you asked the question, why would you just not do this first, right? All right, so, but here's the deal. If we're trying to figure out what the molecule is, if I handed you a bag and I said in this bag there's a certain molecule, okay, there's no way that you can determine what the empirical formula, or excuse me, the molecular formula of that compound is without knowing what the empirical is first. So you have to go through the process of trying to determine what the empirical is to then determine exactly what the molecular is. It's two different compounds. Okay. Now, this is important to make a note of. Is it possible for the empirical to also be the molecular? Hold on. Let me don't say anything out loud. Let me guide these questions. Let me guide the questions. Don't say anything out loud. So I asked the question, is it possible for the molecular formula to also be the empirical? All the empirical means is it's the most reduced version. So answer the question as I go. Is H2O a compound? Is H2O2 a compound? Is H2O an empirical compound? Is H2O2 an empirical compound? No. Is H2O a molecular compound? Is H2O2 a molecular compound? Yes. So this thing is the EF and the MF. It cannot be reduced any further, correct? So the other thing can be reduced. But what do we know about these things? There are no such thing in chemistry. There are no O's in chemistry. Okay? Is that the first time you've ever heard me say that? But I say that's not the first time I've ever said that. But it just makes it kind of come to life when you see it in that version. I did? Okay. So did you didn't? So okay, perfect. That makes me happy that that actually shows up. All right, so let's move on to the next one. The next one says, if you've got 17.6 grams of Na. Now, notice I did a little something different. What did I do different from the problem? I went ahead through the grams in it, so let's do that. So we've got 39.7 grams of chromium, and then I've got 42.8 grams of oxygen. Cool with that? Spectacular. What's the first step? Convert grams to moles. So I've got grams, and I got to go to moles. I've got grams, I got to go to moles. Got grams, and I got to go to moles. Cool with that? Come again? Oh, that's actually a good question. I don't even know the mass of chromium. That's right, it is 52, and it's one of the few that are actually even values. So sodium is 22.99, chromium is 52 even, oxygen is 16 even. So 1, 1, 1. Do y'all like not having to write the parentheses anymore? It makes you, as weird as it sounds, it really makes you appreciate doing this a lot more than not having to do the crappy parentheses. That's fine. What do you mean by shorthand at all? That's fine. Let me put it to you this way. As long as I understand where you're coming from, where your numbers have come from, and where you're going. Trust me, those people are smart enough to know what you're doing. Okay. They're a lot smarter than I am. They'll figure it out. Yeah, units are important, but they're really mainly looking to do you have the right answer. All right, so how many moles is in sodium? Okay, what about moles of chromium? And then moles of oxygen. That got weird. That number. Okay, all right, so here we go. Elizabeth, what's your next step? You got it right last time. Divided by the smallest. Which one is the smallest? Now, you are smart enough to know that that turns into a 1. That turns into a 1. And then I'm going to need your help with the bottom one because that's a little bit. Woo. Uh-oh. Now, if you've had me last year, hush. If you had me last year, do not say a word. This is a problem. You cannot round like normal regular math rounding. This is what I call the 1-9 rule. Okay? The 1-9 rule is The 10th place value must be a 1 or a 9, and obviously a 0, right? To be able to round. A 1 or a 9 to be able to round. That is not a 1, nor a 9, nor a 0. Therefore, what must you do? Okay? So here's the deal. And this happens quite often because people aren't paying attention. You are smart enough to know that if we multiply this by 2, this is going to be what? 7. Here's the problem. Every year I have students that then write their empirical formula as Na1 CR107. The key is, if you change one, it's just like they say in math, what you do to one side, you got to do the other. You can't leave them hanging. You have to do it to the exact, you got to do it to all of it. So that turns into 2, and that turns into 2. Hold that thought. Don't say it out loud. Okay? So then we can write a formula off of that. Justin, I know you know the name, but I'm not going to call on you for it. Nope. No, why would I do that? Madison. Name that thing. Shh. Shh. You just took a quiz on it. You did? I hope you did. Were you present for that? I was. Come on now. Give it to me. Think about it. Think about what C are. Think about what 2 chromiums are. Thank you. Okay? That was on there. Dichromate was. All right, so sodium dichromate is this compound, and I think it's interesting to see that perspective. All right, before I move any further, I want to look at one thing. Hang on one second. So, there's a reason I'm showing you this, and I might want to write this down. So, here's the deal. We have a compound. We have this compound, and this compound is made up of carbon, hydrogen, oxygen, and chlorine. And we don't know how many of each are present, okay? So essentially the goal is to find the empirical formula. We cool with that idea? All right, so here's the deal. What if I told you the entire total mass sample of this thing is 2.678 grams? You out of there? Okay. What if I tell you, now these numbers are not going to be perfect. I'm just making crap up. Okay? It's not going to yield a successful result. I'm talking you through process orientation of if you see these certain types of questions, you need to be familiar with them. Okay, let's pretend, all right, so I'm going to do C, H, O, and Cl. Let's pretend that of that 2.67 grams, that 0.329 is hydrogen. Say that again? Sure. This is not real. Well, hold on. Stay with me. Now, my question to you is, if the question is find the empirical formula, do you agree that you need to know the mass of all of those things? All right, so far I've only given you one. Would you agree with that? Let's pretend that in the question, and it says, excuse me, hold that thought, I'm going to come back to that. What if it tells you something like that? If it tells you that chlorine is 35% of that mass sample, thank you. I might would pay attention to that concept. That if it ever gives you a total, would you agree that this is a total? Would you agree that this is a part? Would you agree that this is a percentage? What is a percent? What are you searching for? You're searching for a part, correct? Mathematically, what would you do? Okay, 0.35 times 2.678. Somebody run that for me. Okay, 0. What? Something like that, give or take. Again, these numbers aren't perfect. These numbers aren't perfect. Okay. Now, this next part is the reason why I'm going through this. That was one issue. But this next part is the reason why I'm going through this, because it's going to be challenging. And you've seen this before. It's been a long time since you've seen it. That's why I'm going to show it to you. Let's pretend that they also tell us that 3.80 grams of CO2 is produced. Let's pretend that's the value they give us. My first question to you is, would you agree that this CHOCl thing is kind of like a hydrocarbon? Can it kind of combust? What about products of combustion? CO2 and water. All right, now, there would be some others because you would have to maintain chlorine, right? So we're just going to ignore that. This is the part that's the most challenging for students, is this next part. The way to find the amount of carbon in the original sample is based on the amount of carbon in carbon dioxide. I'm going to say that one more time, but I'm going to say something before I say it. There's this law called the conservation of mass. Would you agree that if this were combustion, what would this thing have to be reacting with? Oxygen gas, right? Remember, combustion has to have oxygen present. So, in the reactant side, where's the only place carbon is found? Right there. Right here. In the product side, where's the only place carbon is found? Carbon dioxide. So if mass is conserved, the amount of mass you have in carbon and the carbon dioxide, should it also be the exact same mass of carbon you found in the reactant? Yes. That's how you could do it this way. So one more time. To find the mass of carbon in the original sample, you have to determine the amount of carbon in what? Carbon dioxide. Don't tell me how to do it. We're going to do it together, okay? I don't want to get anybody confused. I just want to do it together. So here's the deal. So I'm going to actually change pages just so we'll have enough space. So 3.80 grams of CO2. And this is where it gets really kind of funky. You with me? I have no clue where I'm going, but I know at least what has to be true. What kind of grams? So, we know that I'm going from CO2 to C. Would you agree with that? Yes, very good. So, I know that to get from this to this, what do I have to have? A mole to mole. Now, so if I'm in grams, I at least have to go to moles of CO2. Would you agree with that? Okay. Now, I've got to get rid of moles of CO2, so I know that it's got to go on bottom. Now, I'm going to go back and plug these numbers in. Dustin, you've already told me this, which I already knew. The mass of carbon dioxide is 44.01 and is 1 mole. This next step is the new step for you guys that you may have never done before. And if you have, tell me, because I don't remember if we did it or not. It is called the atom to sir. Can you stand up? Sure. Okay. So what this next step is it looks just like the mole to mole. But I've asked this question to you guys 100 times. Where does the mole to mole ratio come from? The coefficients of a balanced equation. Do we have a balanced equation to work with? No. This is a little different. What this is this is an atom to molecule ratio. It's just as easy to answer. In fact, to me, it's easier. It's how many atoms of that molecule are present in the formula. Yes, you do know. And 1 mole of carbon dioxide, how many moles of carbon are there? 1. So for every 1 CO2, there is 1 C. Hypothetically, what if we were talking about oxygen? What would it have been? 2. You see how simple that is? Do you go off of the subscripts? Yes, that's exactly what you go on. I've been teaching. Peyton, what's up? I haven't had a chance to read it. When did you send it? So again, what we're doing is we're trying to determine how much carbon you have present, correct? Yes. Now here's the deal. We could stop here if we wanted to, but what were we trying to find? The grams of carbon. Now it's just your basic, normal, regular conversion, right? So, ooh, that's the wrong color. I don't like that. So we're going from 1 mole of carbon is how many grams of carbon? 12.0. Are you okay with that? Yes. Of the formula. Yes. If you're trying to get from the compound to a single atom in that compound. Okay? Yes, ma'am. This is only on a combustion question when they give you the mass of the carbon dioxide and you need the mass of the carbon. We cool with that? Can anybody tell me how much this is? Only combustion when you're trying to find a specific atom within a compound. Okay? 1.04 grams. All right, so I'm going to come back to this page and write this down. 1.04. Actually, I hate that. Let's do it in the right color. 1.04 grams. Now, that's fine, I don't care. Okay, hold on. Now, do you agree for this problem, number 1, they gave you the mass of hydrogen. Was that pretty common, pretty simple, right? The second problem was the chlorine. If they give you percentage and you have the total, is it very easy to find how much the part is? Don't mess that up. Now, the one with carbon, that's really difficult. That's the hardest part that people miss. That's the most challenging part. It's finding the amount of carbon in carbon dioxide. But if you really think about it, it's not challenging. Okay? It's just a basic stoic problem. Now, the hardest question, but should be the easiest question, how much oxygen do you have? Never said anything about it. Thank you. I was hoping that was going to be something simple. If this value is missing, it's just like any basic algebra problem. Plug in x and go for it, right? Should all of your parts equal to your total? Add your parts and subtract it from the total. Sir. 2.678. Do what? Do you multiply the top number by the molar mass and divide it by the other one? The total is? Say it again. Okay. Now, these numbers are not going to yield a perfect formula. I made these numbers up. However, once you did this, could you then very easily find the empirical formula? Very easy. What do you do with all those numbers? No. Convert them to moles. Every year, people do all this other stuff. Every year. They do all the hard stuff, and they get the empirical formula, and they just lose their mind. They just start dividing by the smallest grams. It's because their mind is so overworked, focused that I do all of those other steps right. When they get to the step they actually know how to do, because we've done it 100 times, they lose their mind and they forget. They start just kind of screwing everything up. So don't miss the easy stuff. I know empirical formula is not simple, but compared to the thinking that goes involved, the question says, what is the empirical formula? You know what to do. Grams to moles, divide by the smallest number of moles, make sure they're all whole numbers, right? Very simple. Okay, Dustin, what were you going to say? You sure? Okay. Sir. Yes, H it told you in the problem. H is 0.329 grams. That was the percent of the total. Like it's in the problem, it would say that chlorine is 35% of the original mass of the sample. Yeah, I made it up. Okay, sir. That they would. Okay, go ahead. Yes. Yep. Yep. We good on this? I know it's a lot, but it should make sense. And this is the type of problem that you may see. Okay, it's very in depth. It's very detailed. It's very specific. It's not just here's the numbers, plug it in and go. I wanted to make sure your grounding and finding the empirical formula was right first, and then throw the complicated stem at you, which is how you get to actually solving for the empirical formula. Okay? Yes, Dustin. Okay. And you're talking about finding the amount of carbon in CO2. Okay, I'm listening. Okay. That's the number you got to memorize. So basically, if you didn't have it memorized, you're going to have to do math to figure out the percent composition, or you can just run the stoichiometry and be done. Okay, but I mean, okay. Yeah, 3.80. Okay, I see what you're saying. I mean, I see what you're saying, but I mean that's how did you find the amount of carbon and carbon dioxide? Or excuse me, how did you find the percentage? No, just how did you find the percent of carbon and carbon dioxide? So what you're telling me in simple terms that you divided 12.01 divided by 44. 12.01 divided by 44. All right. Here's also another important thing. I also want to tell you that you may have to utilize this step more than just this. And we're going to get to some situations later where we need it. So I want this step to be a part of your repertoire where you can actually say, I know what to do. Does that make sense? Because then it won't always be carbon dioxide. Let me throw this at you. What if they asked in water, I'm going to go back to it. If I have 3.80 grams of water, how many grams of hydrogen do I have? And so I want to throw this at you because I think it's important. If we changed all of this to water, grams of water to moles of water, would your mass change? What would your mass be? And this is H2O as well. This is the important step. Is that still the same? In 1 mole of H2O, how many H's do you have? There are 2 of them. Now, obviously, if we continue, in 1 mole of H, we have 1.01 grams of H, correct? So, you have to be careful with how you look at the atom to molecule ratio. Both rules can apply. If you know that hydrogen is 11% of water, rock and roll. Well, that's something that you're doing the exact same thing I'm doing, except I'm done once I divide the masses. I'm not adding the percentage step to it. Okay, Tristan? Only when it's by itself. It's with water. I've already got it taken care of right there. I understand this, but this is 1 hydrogen. In 1 hydrogen, it's 1.01. Okay? Does that make sense? Yeah, go ahead. Oh. I love it. Let's make it up. Give me something. No, I like it. Give me something. No, give me something, Madison. Okay. Two point oh two. Yes. Okay. In H2O, there is 2 atoms of hydrogen per 1 molecule. Would you agree with that? There are 2 in every one. Would you agree with that? But 1 hydrogen is 1.01. Does that answer your question? Yes. Or you could say this, that 1 mole of H2 is 2.02 grams. But we're not trying to find H2. We're trying to find H. We're not going to do H2. Okay. Remember that diatomic means only when it's by itself. There's nothing else attached to it. Water has oxygen attached to it. So just because it has that H2 doesn't mean because it's a diatomic. That's just how the charges balance it out. Okay? Sir. Hydrogen atom. Yeah, the H in water. Yes. Yes. Does that make sense? Okay. All right. Sir. On the exam, I don't know. But I'm telling you, on the test we take, you're going to see something like this. I promise you, you're going to get them done. Y'all, I mean, we're only a week and a half into there, 2.5 weeks in. I promise you, you're going to get better at this stuff. Yes. You're going to know every bit of it by then. Okay? Don't sweat the small stuff. It'll all work out. Nicole? Yeah. I haven't decided yet. All right. So you'll know plenty of time in advance. All right. So let's move on. All right. We're going to skip C. There's no reason to do it. If you want to go ahead and do C, that's fine. That's just a basic empirical formula, right? I'm sorry. Deal with it. That's going to happen a lot. You had to multiply those by 3, Dustin? Okay, that's fine. Yes. You start with 2, then 3, then 4, then 5, and so on. I'll go ahead and say if you get above 5, you've done something wrong. Start back over. Don't ever go above 5. Really, I've never seen one go above 4. It did, but it was really weird. It shouldn't have done that. All right, so number 3A, oxalic acid has the empirical formula CH2O. Now, let me ask you something. Is CH2O all right to be named an empirical? Yeah, CHO2. Can it be reduced anymore? No, so it's good. its molar mass is 90.04. So the good news is for this question, they've already done the hard work for you, right? They've already found the empirical formula. So to find the molecular, it's just like I showed you a minute ago. It's the mass. So the mass of the MF over the mass of the EF. Now, how do you know the mass of the MF? It's given to you and they tell you it is 90.04. And then we would need to determine the mass of the empirical. So it's 32 plus 12.01 plus 1.01, which is what? 32 plus 12 is 44.01, and so 45.02. Okay? Now, you guys are smart enough to be able to look at that and tell that what is that? It's 2. Okay? Yeah, it is exactly 2, actually. So the empirical is C2H2O4. That is your molecular formula. Okay, the reason it's molecular is because can it potentially be reduced? Yes. Okay. We've got 5 minutes left, so these last 5 minutes, I want you guys to do 3B all by yourself. That's empirical and molecular. If you've already done it, congratulations, but I want everyone to give it a shot.